Okay, let's talk about section 2.3, lines. First, let's calculate and understand the slope of a line. Calculate and interpret the slope of a line. So when we have 2 points, 2 points will uniquely determine a line through those 2 given points. And for those 2 points, let's check the horizontal difference. Okay, this is a horizontal difference of the 2 points. The horizontal distance is called the run of those 2 points, horizontal. Okay, and the vertical distance of 2 points is called the rise. So you have a run, you have a rise. Rise is a vertical, run is a horizontal. Okay, and from the geometry we figure out, if you pick up any other pairs of a point through the from the same line, of course, because this selection of pairs is random, so the rise and the run are random. They may not be the same, but there is a special property between rise and the run, is that the rise over run, this ratio is a constant. Okay, so this is the mathematician found through the practice. Okay, and this constant totally determined by this line. So we call this constant the slope. Okay, let's see the definition. Let P be x1, y1. So we're going to put the coordinates, and the Q x2, y2 be 2 distinct points. If x1 is not equal to x2, so why we care about x1 not equal or not equal to x2? The reason is that, so let's check here. This is x1, y1, first point, x2, y2. Then what is the run? Run is the difference of x coordinate. It's horizontal, so run is the difference x coordinate. So it's x2 minus x1. What is the rise? Rise is the difference of y coordinate. It's a y2 minus y1. So when we form this rise over run, we actually get y2 minus y1 over x2 minus x1. Whenever you have denominator, you have to make sure that this denominator is not equal to 0. When the denominator is 0, x1 is equal to x2. So in order to make the denominator not equal to 0, we assume x1 is not equal to x2. This guarantees you have a non-zero denominator. Okay? When this makes sense, the slope m of the non-vertical line L, this line is called L. Non-vertical comes from x1 is not equal to x2. Okay? Vertical, then x1 is equal to x2. Non-vertical, x1 is not equal to x2. Okay? So this condition and this verb, they are equivalent. Okay, so non-vertical, again, guarantees that the denominator is not equal to 0, so we can form the quotient. The L, this line L, containing P and Q is defined by the formula m equal to y1 minus y2 over x1 minus x2, the rise over run. Again, here we assume x1 is not equal to x2, the denominator is not equal to 0. Okay, so this is a definition of the slope for a non-vertical line. A non-vertical line. Of course, there is the possibility if x1 is equal to x2, then the line L is a vertical line. When you have a vertical line, the slope of L is undefined. So here, if someone says all the lines have slope, that is wrong. This statement is incorrect. All lines have slopes. The statement is incorrect. You can only say all non-vertical lines have slope. Vertical lines have no slope. Undefined means the slope does not exist. Okay? Vertical line has no slope because when you compute the slope, the denominator for vertical lines is equal to 0. You are going to divide a number by 0. That's forever undefined. Okay? So that's a wrong statement. The slope is only defined for a non-vertical line. All right? Okay, so this is one of the most important formulas. Slope is y2 minus y1 over x2 minus x1. Rise over run. And we can multiply top and bottom by -1. For example, if we multiply top and bottom by -1, of course, we do not change the value of this ratio. -1 will exchange the two terms in the difference. A minus b is b minus a times -1, right? A minus b is b times a times -1. So the multiplication by -1 just means exchange the order of the difference. So the slope can be computed by y2 minus y1 over x2 minus x1. By this manipulation, we can see that you can also use y1 minus y2 and x1 minus x2. Okay? It doesn't matter which comes first, but the top and bottom have to be consistent. So if you choose 1 appear first, then the top and bottom both 1 appear first. If you choose 2 appear first, then both 2 are the coordinates of the second point, y2, x2, or y1, x1. You cannot mix them. If you mix them, that is wrong. Okay? Okay, so it is always rise over run. The very important concept, slope. And another explanation of the slope is that y2 minus y1, it is the change in the y direction. So when you change the point x and p and q, when you change the point p and q, what is the change in the y direction? It is y2 minus y1. What is the change of x direction? It's x2 minus x1. So the numerator is the change in y. The denominator is the change in x. in y direction, in x direction. Okay? The change in y, normally we write delta y. Delta y. Okay? The triangle y. Triangle means delta. The change in the Greek letter. The change in x, we say the delta x. Okay? This is a capital delta in the Greek letter. Okay, so what is a slope? In the second explanation, slope is the rate of the change in y and the change in x. Okay, then delta y over delta x is called the average rate of change. Average rate of change of y with respect to x. With respect to x, the change of y with respect to x. Okay, and again, this concept can only be discussed for a non-vertical line. Non-vertical line. All right, so this slope is a property of the line. It's not the property of 2 points, like what we observed at the very beginning. You pick up this pair of 2 points, you get the slope. Or you pick up another pair of 2 points, you compute the slope. They should be the same thing. This is from the trigonometry. Okay? So, first, any two distinct points on the line can be used to compute the slope of the line. Okay, so you don't care. I mean, you don't actually have to find some special point. You can basically randomly choose a point. But whenever you really compute, you will choose special point, because a special point can be easily determined. If you just generally randomly pick up a point, I even have no idea what are the coordinates of those of this point. Okay, so it just this property says you can just pick up your favorite whatever pair of two distinct point. Okay, and second property is that is this one. It doesn't matter which pair of coordinates comes first. So it can be y2 minus y1 over x2 minus x1, or it can be y1 minus y2 over x1 minus x2. Either works. You go back and forth and back, you will have the same slope. The reason is because of this multiplication by -1. Okay, so that's two important property or remark you need to keep in mind. And here, you see, we can interpret the slope as the ratio of rise and run. We can also call the slope the average rate of the change of y with respect to x. Okay, it has two names. Okay. Let's see the example. The slope m of the line containing the points 1, 2 and 5, -3 can be computed as slope. Okay, it's up to you to choose the term. You can use 1 minus 5, 2 minus -3. Remember, it's always subtraction. 1 minus 5, 2 minus -3. y1 minus y2. I'm so sorry. It's a 2 minus -3, y1 minus y2 over x1 minus x2. I got the wrong numerator and denominator. Okay, so you do y first. 2 minus -3, 1 minus 5. 2 minus -3 is a 5. 1 minus 5 is -4. So the slope is 5 over -4. 5 over -4. Okay? So this is the slope. Y first, x second. Y on top, x on bottom. Y on top, x on bottom. All right? So let's see the second example. So compute the slopes of the line we have several lines, L1, L2, L3, and L4, containing the following pairs of points, and graph all 4 lines on the same set of coordinate axes. Okay, so let's try L1. L1 has a pair of 2 points, 2, 3, and Q, -1, -2. Let's compute the slope first, and then we are going to graph those lines. Slope M1, L1 has slope M1. Remember, it's a y minus y. 3 minus is always subtraction. 3 minus -2, 2 minus -1. So 3 minus -2 is 5. 2 minus -1 is a 3. So slope is a 5 over 3. Okay? Remember, top and bottom are both subtraction. You always do the subtraction between the coordinates. L2, P is 2, 3, the same point. And the Q is 3, -1. Then the slope is y minus y, 3 minus -1, x minus x, 2 minus 3. So it's 4 over -1 is -4. 4 over -1 is -4. Line 3, P again is 2, 3, and the Q this time is 5, 3. 5, 3, so the slope M3 is y minus y, 3 minus 3, 2 minus 5, 2 minus 5. 3 minus 3 is 0, 2 minus 5, -3. 0 over whatever non-zero number is still 0. So the slope is 0. L4, P is 2, 3, and Q is 2, 5. Then let's check M4. M4 is a y minus y, x minus x, 2 minus 2. Now 2 minus 2 is 0, denominator is 0, undefined. Okay, so the line 4 has no slope. Slope is undefined. Okay. Okay, so this is the computation of slopes. Now let's graph them. Let's graph them. So one, two, three, 4, 5. 1, 2, 3, 4, 5, 6. 6. 1, 2, 3. Okay, let's try. 2, 3. 2, 3. This is 2, 3. -1, -2. -1, -2 is this line. Just use your ruler to draw it. This is L1. This is L1. Okay. Second, L2. 2, 3. This is still 2, 3. And 3, -1. 3, 1, 2, 3. 3, -1 is here. This is L2. L3. L3 is a 2, 3. This is 2, 3. 5, 3. Here's a 5, 3. 1, 2, 3, 4, 5. 5, 3. The same height. It's L3. L4. 2, 3, and 2, 5. 2, 3 is here. 2, 5. 1, 2, 3, 4, 5. 2, 5 is here. This is L4. You can see that L3 is horizontal. L3 is horizontal, slope is 0. So all horizontal lines have slope 0. Horizontal lines have slope 0. That's the statement, the result. And the vertical line, L4 is vertical. So its slope is undefined. The denominator is 0. L4 has 0 denominator, so the slope is undefined. And the L1 has slope 5 over 3. We know it's a positive. A positive slope means the direction of the line is always northeast. The direction is always northeast. Okay, always this direction, heading to northeast. And L2, this is L2. L2 has negative slope, then it is northwest. So slope is, whenever you see a line like this, here or there, whatever way, whenever you see it heading to the left part, it has negative slope. When you see the line is turning to the right on top, it has positive slope. If it's horizontal, slope is 0. If it is vertical, no slope. Okay, that's the characterization or classification, interpretation of either sign of the slope or the 0 and undefined case for the slope. All right. So it's a slope. The meaning of the slope: positive slope, negative slope, or 0 slope, undefined slope. Okay. This classification, like those 4 cases, is on page 169. There's a yellow box, so you can check it. And if we want a more precise property, it's the following. let's just assume this line passes through the origin. For example, this L1, assume its corresponding slope is 1. It's a diagonal of the first and third quadrant. And it has positive slope because it's turning northeast. Okay, northeast. And if you have an even more flat horizontal line through the origin, it's more flat, more horizontal. If it is even more horizontal, for example, this is L2, then the slope will be less than 1. It's less than M1. I don't give the precise value, but it is going to be less than M1. So a positive and a small slope means that the line is very horizontal. It's very horizontal. So when you rotate it like a clock, the slope becomes smaller and smaller. Eventually it approaches 0. It becomes, once it is horizontal, it will coincide with the x-axis, the slope becomes 0. During this rotation, the slope becomes smaller and smaller. And if you have a more steep, more vertical line, well, I'm talking about heading to the northeast, okay? More vertical line has larger positive slope, okay? It will be larger and larger. Eventually, when it is horizontal, when it is vertical, it's going to be infinity. It will approach infinity. Anyway, we're not going to say anything about approach, but when you have this more vertical line, you will understand, okay, the corresponding slope may be bigger. At least the slope should be bigger than 1, bigger than M1. M1 is equal to 1, okay? Because here, you actually rotate it counterclockwise. This L3 is more steep than L1. L1 has slope 1. L3 will have larger slope, okay? Slope is large, then it is more vertical. More vertical, slope is much more larger. Okay, so this is for the positive case. For the negative slope, assume this is line L1. This is the diagonal of the second and the fourth quadrant. The corresponding slope is -1. And then if you have a more flat line, because of this direction, the slope is negative, and slope will be close to 0. It's more horizontal, it's more close to 0. When it is close to 0, M2 is actually greater than M1. It's for the negative number. Remember, -1/2 is greater than -1. It will be very close to 0, but it's in the negative direction. So M2 is greater than M1. A negative and small slope. Well, close to 0. Let's not use small. Close to 0 slope means that the line is very horizontal. Okay, so whenever you have a line, it is either horizontal this way or horizontal that way, the slope will be always close to 0, because a horizontal line has slope 0. They're almost horizontal, slope will be very close to 0. Okay, and if it's more steep, like this, This is L3. The line L3 is more steep. The slope M3 is more negatively large. What I mean negatively large, for example, this -10, -20, -30, -40, that is negatively large. More steep, more negatively large. Okay, so this is, these two discussions are also on page 169. On page 69, they are figure 30 and 31. They are trying to give you the comparison of between the slopes. Okay. Okay, so now let's try. We are going to graph lines given a point and the slope. How do we do that? So let's see the example. Draw a graph. Draw a graph of the line that contains the point three, 2 and has a slope of, let's see, two cases, 3 and 4, 3 over 4, that's A, and then we'll have B. Okay, let's see how do we do that. So first you have to plot this point, 3, 2. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, 3, 2 means 1, 2, 3, 1, 2. This is a 3, 2. Okay, then how do we use the slope? Slope is a rise over run. It means the run is 4, rise is 3. Positive to the right. Positive, go to right. How do I go to right? Horizontally, you move 4 units. 1, 2, 3, 4. Vertically, you move 3 units. 1, 2, 3. You have the second point. You see, 4 comes from the denominator, 3 comes from the numerator, and you connect those 2 points and extend them, extend the segments. This is a line. How do I know I go to the right? Because it's a positive slope. Positive slope, move to the right. Okay? So that's the first example. And part B, if it is the slope is -4 over 5. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay. 3, 2, 3, 2 is here. This slope is negative. Negative, move to the left. Okay, so how do I do that? Once you determine you will move to the left, you ignore this negative sign. You will see the denominator is 5, so you have 5 units to the left. 1, 2, 3, 4, 5. 5 units is horizontal. Rise is 4. 1, 2, 3, 4. Okay, so it's a second point. Use a ruler, nicely draw it. Okay, so this is a second line. Remember, positive, right, negative, left. Positive, right, negative, left. And what are the units you're going to move horizontally or vertically? If you have a denominator, then you move horizontally according to the denominator. You move vertically according to the numerator. Okay? For example, if you have 3, if the slope is 3, well, how do you use it? It has no numerator and denominator. How do you use it? You just consider it as a 3 over 1. Move horizontally 1 unit, vertically 3 unit. Okay? So that's the trick. And next, this is a graph of the line with slope. We know that not every line has a slope. What line has no slope? Vertical line. Find the equation of a vertical line. Okay, so first, let's see the example. We're going to always do it based on example. Graph the equation x equal to 3. To graph x equal to 3, how do you do that? Before you have any idea or the concepts or the intuition, you always just plot. Okay, so you get x equal to 3, 1, 2, 3, 3. Then you're going to x equal to 3, y can be 1, x equal to 3, y can be 2, x equal to 3, y can be 4. So you just let y be whatever a number you want. X is always 3. This equation requires x to be 3. And once you have sufficiently many plotting points, then you will see it is a vertical line. So x equal to 3 has its graph a vertical line through the x-intercept x equal to 3. Okay, so this number is also the x-intercept. X-intercept, we just call it 3. And there's no y-intercept, no slope. It has no y-intercept, no slope. Right? No y-intercept, no slope. And also from this example, we can see that whenever you have a vertical line, its equation should be like this, x equal to something. Okay? So the theorem, a vertical line is given by an equation of the form x equal to a. A is where a is the x-intercept. A is the x-intercept. Okay, so this moment we can determine the vertical lines completely based on just the x-intercept, a number. So a vertical line is uniquely determined by this number. All right, so that's a vertical line and its corresponding equation. Okay, so in the second part, we already know how to sketch the graph of the line when we have a point and the slope. Okay, so you have a point, you have slope, you know how to sketch the graph. And if you have a point slope, how do you determine the equation? Okay, so that is geometry. To determine the equation, that is algebra. So use the point slope form of a line. Use this and identify horizontal lines. Identify horizontal lines. Okay, so what is a point slope form? Okay, so remember here in our formula we have a point x1, y1, and we have a slope. Slope is m. Okay, so in order to determine the equation of this line, let's randomly pick up a point x. This xy represent a general point on the line. So let xy represent a general point on the line. Okay, for whatever general point, except it is equal to x1, x2. Any other general point, then let's connect them, right? Remember, they are both on the line. For a pair of points, you can compute the corresponding run and the corresponding rise. So the run is x minus x1. Rise is y minus y1. Then rise over run is equal to the slope for arbitrary pairs. So rise over run is equal to the slope. And this formula works out if this general point is not equal to x1 and y1. It's not equal to this point, because if x is equal to x1, the denominator is 0. So in order to remove that possibility, I'm going to move this denominator to the other side. So it's a y minus y1 is equal to m times x minus x1. You just multiply this equation by the denominator. And this is so-called point slope form of the line. Okay? Point slope form of the line. It's an equation. Point slope form is the equation. Okay? Now let's see the theorem. Point slope form of an equation of a line. Okay, so an equation of a non-vertical line with slope m that contains the point x1, y1 is y minus y1 is equal to m times x minus x1 with a parenthesis. Be careful, you have parenthesis. Okay, so this is a point slope form of an equation of the line. Okay, whenever you have a point, you have the slope, then you can write down the equation of the line. And because we're talking about slope, it's non-vertical. Vertical line is already discussed here. Vertical line is x equal to a. Right? Okay, so now let's see the example. An equation of the line with slope 4 and containing the point 1, 2 can be given by what? See, y minus y1 is equal to m times x minus x1. This is x1, this is y1. So it's y minus y1 is slope x minus x1. And that's it. In the exam, I suggest you to just leave the answer like this. Okay? So just leave the answer like this. Because in this exam, in this answer, I can clearly see how you apply the point slope form. Okay, you can always leave it like this. And if we have, okay, this works for all the lines with a slope. And remember that we mentioned there is a special type of a line with a slope. The horizontal line. Horizontal line slope is 0. Find an equation of the horizontal line containing the point 3, 2. Okay, well, let's see. Point slope form, y minus 2 is equal to slope. Where is the slope? Horizontal slope is 0. So it's 0 times x minus 3. Y minus y, x minus x, and times slope. And it doesn't matter what x minus 3 is. Times 0, it disappears. So it's a y minus 2 equal to 0, so y is equal to 2. This is the equation of a horizontal line. And this number 2 is the y-intercept. Horizontal line, of course, will intersect the vertical coordinate axis. Vertical line will intersect the horizontal coordinate axis. That's for sure, right? So from here, we also have the following theorem. It's simple, but let's just list it. Equation of a horizontal line okay, a horizontal line is given by an equation of the form y equal to b, where b is the y-intercept. Okay, b is the y-intercept. So check here, what formulas do we have already? If it's a vertical line, it's x equal to a. A is the x-intercept. You have x, it's x-intercept. If you have a general form, you have a point slope form, y minus y2 is equal to x, m times x minus x. Y minus y1 is equal to m times x minus x1. This is a general point slope form. If you are looking for the equation of a horizontal line, it's a y equal to b. B is a y-intercept. You see, y equal to b, b is a y-intercept. Okay, so for different types of a line, you will have different formula. All right, so this is the first few part of section 2. What is this number? 2.3. We are going to continue this discussion in the next video. Okay, we're not finished. Okay, so let's finish this video and continue in the next one.